Welcome back to chapter 4 of our final online class of a data communication course. This session 3 will explore wide area network technologies. In our previous session, we examined LAN connecting devices and LAN Ethernet standards. Now we will turn our attention to the world of wide area network or WAN. Dynamic packet processing over globally distributed spaces. We will cover layer 3 path determination, WAN encapsulation protocol, and WAN connection services. Let us begin with the fundamental function of routers in a wide area network environment. Routers operate at layer 3 of the OSI model, analyzing logical IP addresses, boundaries, to direct traffic across network systems, unlike bridges and switches that work at the data link layer with MAC address. Routers make decisions based on the logical IP addresses, allowing them to connect different networks and route traffic across the internet. Routers segment both collision and broadcast domains to secure systems and improve network performance. They calculate optimal paths using the mathematical dynamic routing protocols, which continually exchange information about network topologies to determine the best path for data transmission. This path determination capability is what enables the internet to function as routers across the globe work together to deliver data packets from source to destination efficiently. Now, let us examine WAN encapsulation protocol. These are layer 2 encapsulation standards that facilitate long-distance synchronous WAN transmission. The first protocol is HDLC, or high-level data link control, which is a synchronous framing layer standard for a point-to-point leased connections. It provides a reliable, error-controlled method for transmitting data over dedicated WAN links. The second protocol is the PPP, or point-to-point protocol, which is derived from the HDLC, but adds robust authentication through protocols like CHAP, CHAP, or PAP, as well as payload encryption. The PPP is widely used for dial-up connections, DSL, and other point-to-point links because it can support multiple network layers protocols and includes features for link quality monitoring, dynamic IP addressing assignment. The third protocol is the ATM, or asynchronous transfer mode, which transports data via fixed 53-byte cells to guarantee constant transport latency. ATM is particularly well suited for voice, video, and data integration because its fixed cell size ensures predictable delays, making it ideal for real-time applications such as VoIP and video conferencing. Let us explore WAN connection service, which determine how data is actually transmitted across the wide area network. There are two primary types, circuit switched and packet switched. The circuit switched network establishes a dedicated physical path between connection nodes before active transfer begins. This provides a guaranteed constant bandwidth, which is excellent for voice communication and other real-time applications. However, the downside is that underutilized lines remain built and the circuit remains reserved even no data is being transmitted, which can be inefficient and costly. Classic examples include the traditional telephone network and the ISDN. The other one, packet switch networks, on the other hand, breaks application data payloads into small packets, routing them dynamically across the network. This approach provides optimized resource utilization because multiple users can share the same bandwidth. It also enables automatic rerouting on failure, increase resilience and reliability. Packets from different sources can interleave on the same links, maximizing efficiency. The internet itself is built on the packet switching principles, which protocols like IP and MPLS enables the flexible, scalable communication we rely on today. To summarize this third session, we have explored the key concepts of WAN technologies. We learned that routers operate at layer 3, analyzing logical IP addressing to direct traffic and calculate optimal paths using dynamic routing protocols. We examined the WAN encapsulation protocol, including the HDLC for synchronous point-to-point links, the PPP, adding authentication and encryption, and ATM using the fixed 53 byte cells to guarantee constant latency. We also distinguish between circuit switch services, which establish dedicated paths with guaranteed bandwidth but at high cost, and packet switch service, which breaks data into packets for efficient resource utilization and automatic rerouting. Understanding these technologies is essential for designing and managing networks that span cities, countries, and continents. This concludes our coverage of Chapter 4 on the LAN and WAN technologies. Thank you for watching, and I look forward to see you in the next face-to-face class.